In the annals of human exploration, few endeavors have captivated our imaginations like the journey to the moon. The Apollo missions of the 20th century stand as a testament to our species' indomitable spirit, a beacon of ingenuity and courage that illuminated our place in the cosmos. Now with the Artemis program we stand on the precipice of a new era of lunar exploration, one that promises to extend our reach further than ever before. At the heart of this ambitious endeavor lies Artemis 3, a mission that aims to land the first woman and the next man on the lunar surface, marking a pivotal moment in our quest to explore the cosmos. This mission represents not just a return to the moon, but a giant leap towards a future where humanity establishes a sustained presence beyond Earth. Artemis 3 is slated to touch down at the lunar South Pole, a region of immense scientific and strategic interest. Unlike the familiar equatorial landing sites of the Apollo missions, the South Pole presents a unique set of challenges and opportunities. The region is characterized by extreme variations in light and temperature, with some areas perpetually shrouded in shadow. These shadowed craters are believed to harbor water ice, a precious resource that holds the key to unlocking long-duration lunar missions and potentially fueling future journeys to Mars. However, the rugged terrain and extreme conditions of the South Pole also pose significant risks to mission success. The complexities of this endeavor extend far beyond the challenges of landing on a celestial body hundreds of thousands of miles away. Artemis 3 represents a complex tapestry of cutting-edge technology, intricate systems, and human endeavor, all interwoven with the inherent risks of space exploration. From the mighty Space Launch System rocket that will hurl the Orion spacecraft towards the moon to the innovative human landing system that will ferry astronauts to and from the lunar surface, every element of the mission is a testament to human ingenuity. However, alongside the excitement and anticipation, we must also acknowledge the very real risks and challenges that lie ahead. The Aerospace Safety Advisory Panel, an independent body tasked with reviewing NASA's safety practices, has raised concerns about the mission's ambitious timeline and the untested nature of many of its critical elements. These concerns highlight the importance of rigorous testing, meticulous planning, and a steadfast commitment to safety as we venture further into the cosmos. Space exploration by its very nature is fraught with risk. Every mission that ventures beyond the protective embrace of Earth's atmosphere confronts a myriad of hazards, from the unforgiving vacuum of space to the potential for catastrophic system failures. The Artemis 3 mission, with its goal of landing humans on the lunar South Pole, a region never before explored by humans, amplifies these risks. The Aerospace Safety Advisory Panel has expressed particular concern over the first-time nature of many of the mission's critical milestones. These milestones represent uncharted territory in human spaceflight, each carrying its own set of uncertainties and potential pitfalls. For instance, the lunar South Pole presents unique challenges for landing and surface operations due to its rugged terrain and extreme variations in light and temperature. The human landing system, designed specifically for lunar descent and ascent, will be undergoing its maiden voyage with no prior experience to draw upon. Furthermore, the mission will involve a complex series of maneuvers in lunar orbit, including the rendezvous and docking of the Orion spacecraft with the human landing system. This critical operation, essential for transferring astronauts between the two vehicles, will be conducted in a highly dynamic and unforgiving environment, with little room for error. The Aerospace Safety Advisory Panel has stressed the importance of thorough testing and simulation of these critical operations, ensuring that both hardware and crews are adequately prepared for the challenges ahead. The untested nature of these elements introduces a level of complexity and uncertainty not encountered in previous lunar missions. While NASA has a long and storied history of overcoming technical hurdles, the Artemis 3 mission pushes the boundaries of human spaceflight, demanding an unwavering commitment to safety and a willingness to adapt to unforeseen circumstances. As the Orion spacecraft plunges back into Earth's atmosphere at breakneck speeds, it encounters temperatures hotter than the surface of the sun. Shielding the crew from this inferno is the spacecraft's heat shield, a critical component that must withstand the extreme conditions of atmospheric re-entry. During the Artemis 1 mission, an uncrewed test flight of the Orion spacecraft, the heat shield experienced unexpected charring and spalling upon re-entry. While the spacecraft and its test dummy crew successfully splashed down in the Pacific Ocean, The heat shield's performance raised concerns about its ability to protect human crews during future missions. NASA engineers have since conducted extensive analysis of the Artemis 1 heat shield data, identifying areas for improvement and implementing corrective actions for future heat shields. These actions include modifications to the heat shield's material composition and design, aimed at enhancing its ability to withstand the extreme temperatures and forces of re-entry. Furthermore, NASA has adjusted the Artemis 2 entry trajectory to accommodate the existing heat shield, minimizing the thermal loads it will experience during re-entry. However, the Aerospace Safety Advisory Panel has yet to review the engineering details and risk assessments of these changes, and plans to do so in early 2025. The panel's assessment will be crucial in determining the adequacy of NASA's corrective actions and ensuring the safety of future Artemis missions. Section 4. Funding the Future, the Perils of Budget Uncertainty. Just as a rocket requires a steady supply of fuel to reach orbit, so too does space exploration require a consistent and predictable flow of funding. However, NASA's budget, like many government agencies, has been subject to fluctuations and uncertainties, impacting the agency's ability to plan and execute missions effectively. The ASAP has repeatedly expressed concerns about the impact of budget uncertainty on NASA's operations, highlighting its potential to undermine safety and increase risks. Persistent budget uncertainty creates a ripple effect throughout the agency, impacting everything from long-term planning and technology development to day-to-day operations. Delays in funding can lead to project delays, stretching out development timelines and driving up costs. This, in turn, can force difficult choices between maintaining existing programs and investing in new technologies, potentially hindering innovation and progress. Moreover, budget uncertainty can create a climate of instability, making it challenging to attract and retain top talent. Skilled engineers and scientists may be hesitant to commit to long-term projects facing an uncertain future, potentially leading to brain drain and a loss of expertise within the agency. The ASAP has emphasized the need for a stable and predictable budget for NASA, allowing the agency to plan for the future, make informed decisions, and execute its missions safely and effectively.